This is on page 2 of your class packet, and this chapter we're looking at sequences, which is a list of numbers, usually with a pattern, and we're looking at a certain type of sequence called an arithmetic sequence, which is a sequence with a constant rate of change, meaning, addition, and subtraction. So these 3 examples, we're going to determine if it's arithmetic, and if so, state the common difference, which is just that constant rate of change. So this first one is arithmetic because we're going up by 5s every time. So yes, it's arithmetic, and then common difference we'll use as D would be 5 because that is what we're adding every time. The second one, I go up by 3, and then I go up by 4. So this is not arithmetic. Even though I'm adding, I have to be adding or subtracting the same number. And the last one is also no, because even though I'm multiplying by 2, multiplication is not arithmetic. All right, so let's go to the next page. So the whole point of this chapter is when we have an arithmetic sequence, we may be asked to find the 150th number in the sequence. Well, you don't want to sit here just adding until you get to your 150th number. So instead, we have this formula that helps us find any number in the sequence without having to sit there and add and subtract over and over and over again. So for example, this one, it's arithmetic because I'm adding 2. So my common difference would be 2. And I'm going to use this formula to find, let's say, not A of 15, let's say A of 500. So first I need to set up my formula. So it's going to start off as A of n equals A of 1. What this means, this is function notation. It's like f of x that we did in our review sets earlier in the year. A of 1 means what is the first number in the arithmetic sequence. The first number in this sequence is 2. So I'm going to replace A of 1 with 2 plus the n minus 1 and then times D. Well, D is going to be your common difference, which is 2 in this case. So this is my explicit formula. Now, this formula I can use to find any number in the sequence that I want. I could find the 500th term, which we're going to find. I could find the 150th. I could find the 60th. I could find the 700th without having to sit here and go plus 2, plus 2, plus 2, plus 2, plus 2. So basically when you set up this formula, all you need to know is the first term and the common difference. Then your formula is set up. So now to find A of 500, instead of A of n, it says A of 500, so that means I'm replacing all the n's with 500. So it looks like that. So my final answer has to be the 500th term of the arithmetic sequence is this. You could put straight into your calculator, but if you put it in your calculator, you got to make sure you have parentheses where I have parentheses, or you're going to get the wrong answer. And you get 1,000. So again, what that means is the 500th term in the arithmetic sequence is 1,000. This example down here is arithmetic because we're adding 1. So my common difference would be 1. And I got to set up my formula. So it'd be A of n equals, number A of 1 means what is the first number in the arithmetic sequence. That would be negative 3. Then times D, D is 1. So there's my formula, and again, this can be used to find any number. You could find the 50th term in the sequence, or you could find the 70th, 5th term in the sequence. It doesn't matter. all you would do is plug these in for n and solve it just like we did this one up here. The recursive formula, it's kind of useless. I wish I didn't have to teach it, but I do. It's not useless, but it's not useful to solve any term in the sequence. This one is one we use to find any number in the sequence that we want. This one we will not have to solve for, we just need to set it up. So for example, this is arithmetic because I'm adding 7 every time. So my common difference would be 7. And if I want to set up this formula, it would just be a of n equals all this stuff. But instead of plus d, I'm going to put plus 7 because d is 7. And that's it. That's your recursive formula. So again, on your test, you're just going to have to write the recursive formula, but you'll have to not only write out the explicit formula, but this is the one you actually solve for. This one I just kind of got to know that you guys know how to write it out, and that's it.